let's start with GCF. GCF stands for greatest common factor. So what this basically means is if we have certain numbers like 3, 6, and 9, which number of all of these, which common number can we divide all of these by? That's also the largest. So I know that's confusing, but in this case, we see that we can divide all of these numbers by 3. We can divide this number by 3, this number by 3, and this number by 3. That makes 3 the biggest number possible that we can divide all these numbers by. And this will come into play when we start to do factoring. So let's get into factoring. So factoring, there's two ways to factor. The first way is if the coefficient for x squared is 1, and the second way is when the coefficient for x squared is greater than 1. So first let's start with when the coefficient is 1. So here we have a problem. And while it may look like the coefficient is greater than 1, we need to remember GCF. So finding the greatest common factor of a quadratic is the first step to factoring. Here we can see that all of these numbers are divisible by 2. That means 2 is our greatest common factor. So we're going to take 2 outside of a parentheses and essentially divide all of these by 2. So then it'll be x squared minus 3x minus 10. And now we can see that the coefficient is 1. So that means we can do the first method. The first method, we have to do a times c. A is going to be the coefficient for the first variable and the last number. So we're going to multiply those two because it's 1. That's why this makes it so much easier. Because it's 1, we're gonna make this big X shape, and we're gonna do that a times c and put it at the top. So that's gonna be negative 10 at the top. Then we're gonna take this b value and put it at the bottom. So that's gonna be negative 3 at the bottom. Now we have to find which two numbers multiply to equal the top and add to equal the bottom. So in this case, it's going to be negative 5 and 2. Negative 5 times 2 equals negative 10, and negative 5 plus 2 equals negative 3. And so now it's really simple to find our factor. And these are the two factors of this quadratic. So it's going to be 2, and then we're going to do parentheses, x minus 5 because it's negative 5. And for the second parentheses, x plus 2. And this is our factoring of the quadratic, and that's it. 3, 2, 1. Now if we set the numbers in our parentheses equal to 0, we can find the x-intercepts of the quadratics and the roots. But that's another story. So let's go into the second part, when our coefficient for x, or our a value, is greater than 1. Okay, here we can see that our coefficient is greater than 1. First we define if there's any GCF. We know that these are all prime numbers, so that means there's not going to be a GCF. So then we can start by doing the second method. The second method is a lot like the first method. We're going to make our similar X shape, do a times c to get negative 10, and then put the bottom, which is 3. And we're still going to do the same thing, find which two numbers multiply c equal to the top and add c equal to the bottom. And this case is going to be opposite of what the last one was, 5 and negative 2. But this time, instead of just making the parentheses and finishing with these two factors, we have to actually plug them back in. So what I mean by this is we're going to do 2x squared, and then we're going to substitute these two in for the 3x. So then we're going to say minus 2x and then plus 5x, because like we said, 5 and negative 2 equal 3. So it's going to equal out, and then minus 5. Why we do this is so that it makes it easier for doing some more GCF in our factoring. So I put the negative 2 here and the 5 here instead of reversing them, because 5 and 5 are similar, so it's just going to make it easier for us in general. So now there's 4 digits. So what we can do is we can actually split this in half and pretend they are separate quadratics that we have to factor, and this one's a linear function. But Now let's factor these separately. So let's do the GCF first. And the GCF is going to be 2x because there's 2x in both of these. So we're going to take out 2x and do x minus 1 because we divide both sides by 2x. So then this one's done, and then this one is just going to be 5. The GCF is 5, so take out 5, and then x minus 1. So now we have to combine these two. So how we're going to combine them is, as we can see, the x minus 1 is same in both of these GCF factorings. So what we're going to do is we're going to combine those two. So now it's just going to be a singular x minus 1. And then, because we combined those two, so we have to combine our two GCFs, or our outside numbers. So we're going to say 2x plus 5, and put those in parentheses. Now, this is our factored quadratic. And that's how we do GCF